Hello everyone, myself Akash, studying at Sri Venkateswara College of Engineering, bearing the USN 1V21 EC 004. Today I'll be discussing about the topic Role of Modulation Techniques in the Evolution of Wireless Communication. The contents of today's topics are Introduction to Modulation Techniques, Evolution of Modulation Techniques, Modulation of Different Generations, Impacts and Challenges, Conclusion. Introduction to Modulation Techniques in Wireless Communication. Modulation techniques plays a crucial role in the evolution of wireless communication. They enable the efficient transmission of information over wireless channels. Different modulation techniques have been developed over time to meet the growing demands of wireless communication systems. Modulation techniques have played a crucial role in the evolution of wireless communication from first generation to fifth generation. Modulation refers to the process of encoding information onto a carrier signal for transmission. Advancements in modulation techniques have enabled higher data rates, increased spectral efficiency, and improved quality. Definition of modulation techniques. Modulation is the process of varying a carrier signal in order to embed information. Modulation techniques allows for the transmission of digital or analog information over wireless channels. Tech- these techniques convert the baseband signal to a higher frequency of wireless frequency. Importance of modulation techniques. Modulation techniques enable efficient use of the available frequency spectrum. They allow for simultaneous transmission of multiple signals over the same channel. Modulation techniques help improve the signal to noise ratio, enhancing the overall performance of wireless communication systems. Evolution of modulation techniques. Early wireless communication systems used simple modulation techniques like amplitude modulation and frequency modulation. As technology advanced, more sophisticated modulation techniques were developed such as phase shift keying and quadrature amplitude modulation. Modern wireless communication systems utilize complex modulation techniques like orthogonal frequency division multiplexing and quadrature phase shift keying. Amplitude modulation. Amplitude modulation is a modulation technique where the amplitude of the carrier signal is varied to represent the information. It is commonly used in broadcasting and audio communication. Amplitude modulation suffers from low spectral efficiency and is susceptible to noise and interference. Frequency modulation. Frequency modulation is a type of modulation techniques where the frequency of the carrier signal is varied to represent the information. It is widely used in radio broadcasting and mobile communication. Frequency modulation provides better signal and noise immunity compared to amplitude modulation. Phase shift keying. PSK is a digital modulation technique where the phase of the carrier signal is varied to represent the information. It is commonly used in wireless local area networks and satellite communication. PSK allows for higher data rates and improved spectral efficiency compared to analog modulation techniques. Quadrature phase shift keying. QPSK is a digital modulation technique that uses four different phases shifts to represent 2 bits per symbol. It provides higher data rates and spectral efficiency compared to simpler modulation schemes. QPSK is used in digital satellite communication and wireless data transmission. 1G modulation techniques. The first generation of wireless communication primarily used analog modulation techniques such as frequency modulation. Frequency modulation allowed for voice transmission but had limited data capabilities. 1G systems operated at lower frequencies and had lower data rates compared to later generations. 2G modulation techniques. 2G introduced digital modulation techniques, specifically time division multiple access and code division multiple access. TDMA divided the available frequency spectrum into time slots, allowing multiple users to share the same frequency band. CDMA utilized unique codes to separate different users, increasing capacity and enabling better signal quality. 3G modulation techniques. 3G brought about the use of wideband code division multiple access and orthogonal frequency division multiplexing modulation techniques. WCDMA provided higher data rates and improved capacity compared to 2G systems. OFDM allowed for efficient data transmission in the presence of multipath interference and provided increased spectral efficiency. 4G modulation techniques. The 4G introduced long-term evaluation or the long-term evolution as the primary modulation technique. LTE used orthogonal frequency division multiplexing access and multiple input multiple output techniques. OFDMA enabled higher data rates, increased capacity and better spectral efficiency, while MIMO improved signal quality and coverage. 5G modulation techniques. 5G is expected to utilize advanced modulation techniques such as filtered OFDM and universal filtered multi-carrier FOFDM and UFMC aim to address the limitation of traditional OFDM, including high peak to average power ratio and out of band emission. These techniques are expected to provide even higher data rates, ultra low latency, and improved spectral efficiency in 5G systems. The benefits of modulation techniques. Modulation techniques have allowed for the evolution of wireless communication by enabling higher data rates. Improved spectral efficiency has allowed for more efficient utilization of the limited spectrum of the frequency. Advancement in modulation techniques have also led to enhanced signal quality and coverage, providing a better user experience. Impact of modulation techniques on wireless communication. Modulation techniques have facilitated the development of wireless communication systems with higher data rates and improved spectral efficiency. They have enabled the growth of various wireless applications, including mobile communication, internet connectivity, and Internet of Devices. Modulation techniques continue to evolve to meet the increasing demands of wireless communication. Challenges in modulation techniques. As modulation techniques evolve, new challenges arise such as higher computational complexity and increased power requirements. Interference and noise in wireless channel pose challenges to achieving optimal performance with advanced modulation techniques. Standardization and compatibility across different generations of wireless communication systems can be a challenge when introducing new modulation techniques. Future trends in modulation techniques. Future modulation techniques will focus on improving spectral efficiency and increasing data rates. The integration of advanced coding techniques and error correction algorithms will enhance the reliability of wireless communication systems. Modulation techniques will also adapt to new frequency bands and technologies such as 5G and beyond. Conclusion. Modulation techniques have played a vital role in the evolution of wireless communication from 1G to 5G. Each generation has introduced new modulation techniques to improve data rates, spectral efficiency, and quality of the signal. The continued development of modulation techniques will be crucial for the success of future wireless communication system. Thank you.